Hello. Today's objective is that you use properties of logarithms. Now, you see there's a table here. So we've got 6 examples to go with the 3 properties of logs. And I'll briefly just state what each one is. The first property says that when you are adding two things, log base b of x plus log base b of y, you can condense them into a single log with the same base by multiplying what's inside. The second property is the exact same thing, except instead of adding, you're subtracting the logs, and so not a surprise, instead of multiplying what's inside, you divide what's inside. And then the third one states that when you have an exponent, a coefficient in front of a log, that coefficient can be written as an exponent of the stuff that's inside that log. So when you go from a longer expression to a shorter expression, that's called condensing. And then going from a shorter one to a longer one is called expanding. And both of them are useful at various times. So the first condensing example that we used for this first property says log base 5 of 11 plus log base 5 of 2 plus log base 5 of w. Since each of these logs have the same basis and they're all being added, we can condense this to log base 5 of 22w. Now, I skipped a step here. I didn't write 11 times 2. I just simplified it to 22, but I'm assuming most of you guys are going to be okay with that. This is a type of problem where a lot of times you'll see a lot of work, but I actually think it's easier to just look at what you started with and look at the answer, and you can kind of see where things went. The same problem going backwards then has natural log of 4xy. Well, notice there's 3 things being multiplied here. 4 times x times y with a natural log. So I can break this into 3 natural logs. Natural log of 4 plus natural log of x plus natural log of y. And they're all plus because they're all multiplied by each other. So our second example, or our second row, has to do with the second property, which is that if you're subtracting things and you divide them. And I'm going to write my answer over here because you're going to see we're going to simplify it. We've got 2 logs base 10, which means we can condense them. They're the same base. So I'm going to write log of 9x to the 5th divided by 6x squared. And again, since we subtracted logs with the same base, we were allowed to just divide what was inside of them. Now you notice here this obviously simplifies, so I'm going to do that. This gives me log 9 over 6 reduces to 3 halves. And then x to the 5th divided by x squared. Using exponent rules, you subtract those, and this comes out to x cubed. You also could have written the x cubed in the numerator. The expand example for the second property, notice we've got 3 things that are inside, a 6, an 11, and an x. And there's different ways to do this, but I'm just going to show you one. I'm going to expand this to be log base 9 of 6. And then since both the 11 and the x are being divided, I'm going to subtract both of their logs. So I'm going to write minus log base 9 of 11, and then another minus log base 9 of 6. Again, there are other ways to think about this. This is just one, but any way you do it, you're going to get the same answer in the end. Finally, we get to the coefficient to exponent 1. So this one, honestly, this one, you'll notice the example also is going to use some of the other properties, and they usually do. So what this says is that when you have a coefficient, it can be written as an exponent of what's inside. So this is going to end up being 5 squared. It'll be 25. This 8 is going to become x to the 8th, and that 3 is going to become y to the 3rd. Then, since these are all added together, we can combine them all into the same log. Natural log because it's base e. So this is going to be natural log of 25. That's 5 squared. X to the 8th. And then y to the 3rd. And that's it. Expanding, you notice we've got 3 things inside of this log, a 5, an x, and a w. The 5 has an exponent just of 1, so I don't need to worry about that. But the x has an exponent and the w has an exponent. So when I expand it, I'm going to have 3 logs. The first log is log base 2 of 5. You can write a 1 out front if you want, just to remind yourself that it had an exponent of 1. Plus 3 log base 2 of x. So you see where the 3 came from. It was that exponent. and then minus, because it's in the denominator, it was divided, 2 log base 2 of w. Again, I'm out of space, but I think you see it. And that's it. You can show work for this if you want. You can always show more work, but hopefully when you look at the answer and you look at the problem, you can see exactly where it came from. So our objective was that you use properties of logarithms. Again, there's 3 of them, and these 3 properties can be used forwards or backwards by condensing or expanding.